Hello everyone, today I am representing electromagnetics or electromagnetic field theory from Markus Zahn. This is problem number 10. In this question it is given that find the magnetic field at point P shown for the following line currents. In our question A it is given that it is a rectangular loop of dimensions A and B and which is carrying a current I. For solving this question, first we will consider a line segment, a straight conductor which is carrying a current I, and we will consider there is a point P and there is a point Q, and we will join this point P and Q. If we join this point P and Q, then we will find the radius vector RQP. This radius vector RQP is equal RQP, and let this distance is equal to S and this distance equal to X, and we'll again consider a small element on the wire is dx. Now from this figure we can see that our radius vector RQP is equal to minus x ix cap minus s iy cap, and its unit vector I x or RQP IQP cap will be equal to minus x ix cap minus s iy cap divided by x square plus s square to the power half. Now from the, and again the dl length dl is equal to dx I cap. Now by Oersavart law for finding magnetic field, B is given as B is equal to mu naught divided by 4 pi integral of I dl cross I QP cap divided by RQP square. Now we will substitute the value of all this parameter. Then we will find B will be equal to mu naught divided by 4 pi integral of I, and instead of dl we will write it as dx I cap ix cap cross IQP will be equal to minus x ix cap minus s iy cap divided by x square plus s square into x square plus s square to the power half, and its limit of this integral is equal to from minus L to plus L. Therefore we can find the value of magnetic field B will be equal to mu naught divided by 4 pi there is I, and if we carry this cross product there will be S, and in denominator, and again there is dx divided by x square plus s square. There will be again x square plus s square whole to the power 3 by 2 with limits, lower limit equal to minus L and upper limit is equal to plus L. So if we carry this integral, then its value will be equal to mu naught I s divided by 4 pi into 2L divided by S square into X square plus into L square plus S square to the power half. Now we can cancel this 2 and this 4 and this S and S square of this S. Therefore, our value of magnetic field for a straight current carrying conductor will be equal to mu naught I L divided by 2 pi S multiplied by L square plus S square whole to the power half. Again, for this rectangular loop, first we consider this segment, this upper segment. For this upper segment, L equal to A divided by 2 and S equal to B divided by 2. Therefore, B1 will be equal to mu naught I, and instead of L we will write A divided by 2 divided by 2 pi, and instead of S we will replace B divided by 2, and again instead of L we will put A divided by 2 means A by 2 square plus A by 2 square plus B by 2 square to the power half. So we can write B1 as B1 equal to mu naught, or we can cancel this 2 and this 2 as well. Therefore we can write this value will be mu naught IA divided by 2 pi B into there will be 2, and in denominator there will be A square plus B square to the power half, and this 2 and this 2 will again get cancelled. Therefore, we can write B1 is equal to mu naught IA divided by pi B into A square plus B square whole to the power half with its direction IZ cap. And again we are seeing there are two symmetrical parts. Therefore, net B1 is equal to 2 times of this quantity. Again, similarly, if we replace L equal to B divided by 2 and S equal to A divided by 2, then we'll find B2 will be equal to 2 mu naught I B divided by pi A into A square plus B square whole to the power half with its direction IZ cap. Now the net magnetic field B net will be equal to B1 plus B2, which is equal to 2 mu naught I divided by pi into A square plus B square whole to the power half multiplied by B divided by A divided by B plus B divided by A. and its direction is equal to iz cap. If we simplify this value, then our net magnetic field B net will be equal to 2 mu naught I divided by pi a square plus b square into, there will be AB and there is a square, there is b square. Now as there is a power half, so this term will get cancelled and there will be only one half power, and its direction is equal to iz cap. Therefore we can write our net magnetic field B net is equal to 2 mu naught I divided by pi AB multiplied by a square plus b square whole to the power half with its direction iz cap. So this is the solution for the question of part A. Again we can solve this question in different way also. If we want to solve this question in different way, then we'll use the Biot-Savart formula in another form. For that case, first we'll draw the rectangular loop. This is the rectangular loop. And this is the center of the loop, and we'll consider the point here, and this direction is equal to, this point is P, and its dimension, this is a divided by 2, this is again a divided by 2, this is b divided by 2, this is again b divided by 2. Now if this angle is equal to theta, this angle is equal to theta, then we can write tan theta is equal to a divided by 2 divided by b divided by 2, which is equal to a upon b. So if tan theta is equal to a by b, let this angle is equal to theta, this is a, this is b, so its length of the hypotenuse is equal to under root a square plus b square. From this diagram we can write sin theta is equal to a divided by under root a square plus b square. Now this is our first segment, this is our second segment, this is our third segment, and this is our fourth segment. So for first segment, the magnetic field B1 is equal to mu naught divided by 4 pi I upon R and multiplied by sin theta plus sin theta. It means 2 sin theta. 2 sin theta. Now we'll substitute the value of sin theta. It will be mu naught divided by 4 pi I upon R. Now this R is equal to B divided by 2. And there will be 2, and value of sin theta is equal to A divided by under root A square plus B square. So our value of magnetic field B1 will be equal to mu naught. Now this term and this term will get cancelled. After cancelling, we can write B1 equal to mu naught IA divided by pi B under root A square plus B square. Now from this diagram, as we are seeing that 1 and 3 are symmetrical, therefore B net B1 will be equal to 2 times mu naught IA divided by pi B under root A square plus B square. Similarly, if we want to find this angle, let this is phi and this angle is equal to again phi. So from this diagram, we can write tan phi is equal to B divided by A. So this is our angle phi, this is our height B, this is base A, or we can say sin phi is equal to B divided by under root A square plus B square. Again, magnetic field B2 due to the second segment will be equal to mu naught divided by 4 pi I upon R. Now the value of R is equal to A divided by 2 into 2 times sin phi, and value of sin phi is equal to B divided by under root A square plus B square. Now this term get cancelled, therefore we can write B2 equal to mu naught IB divided by pi A under root A square plus B square. And as we are seeing that segment 2 and segment 4 are identical, therefore we can write B2 net will be equal to 2 times this value. So our net magnetic field B net will be equal to B1 plus B2, which is equal to 2 mu naught I divided by pi under root A square plus B square multiplied by A upon B plus B upon A, and its direction is equal to I Z cap, or we can write B net equal to 2 mu naught I divided by pi under root A square plus B square, and there is A square plus B square, and there is AB. Now this if this cancel, then there will be only power half with its direction IZ cap. So B net or net magnetic field for this loop will be equal to 2 mu naught I A square plus B square whole to the power half divided by pi AB with its direction IZ cap. So this is the solution of part A of problem number 10.